not, then I'm going to start the course. Okay, like a good number, more than 30 students join this course. And then let me now share this screen. Okay, can you see the screen sharing? Is it there? I think. Okay. Okay, so can you see the full screen? I suppose yes, right? So okay. Now, in this lecture, we are going to talk about other solutions other than what we have discussed in the past, including solar panel and nuclear power, wind energy, and also electric vehicle that help to reduce emissions. And so today we are going to introduce a few more solutions, either different types of renewable energies or how to capture carbon back from the atmosphere or before it is released to the atmosphere. Okay, so today is talk about other solutions. Okay, so these other solutions could either be new energies or some technologies that can reduce carbon emissions. Okay, and as I believe that you should have watched the video, right, regarding there are two videos. One is the wave energy, and other one is on the carbon capture. Okay, there are another a small topic on thermal heat and ocean thermal energies, and I didn't prepare the video for this small topic, but I will talk about this topic in this Zoom tutorial. You can send any questions on the chat room if you want to stop me or ask any questions. Okay, so let's start with the wave energy. There are many different types of wave energy. The first one, or sometimes we also call the hydro energy, or sometimes we also call it tidal energy. Tidal means the tide in the sea. High tide and low tide will cause the water flow from the oceans to the river, or in the low tide in the evening, water will flow from the river regions back to the oceans. So if you install a turbine at the entrance of this river delta, then in the morning during high tide, water will flow in, and then in the evening during low tide, water will flow out, and then you can capture the energy flowing through this river delta. Okay, one of the installation is to install this turbine and generator at the entrance of this river delta, and then submerge it under the river or sea. And but there is a problem that the maintenance of this type of design is not easy. You need to ask a diver to dive into the sea and then to do the replacement or repair. Okay, therefore you should have also watched the video, right? Another video showing how when the water wave come close to the shore, then it will compress and decompress the air inside this chamber. Okay, so in this case, you can make use of the air chamber, and then there is a turbine flowing through in this dry area. Okay, not submerged in the sea, so that is easier for us to do maintenance. And when water level of this wave go up and down, air will be compressed in and out, and then generate electricity. Okay, so this is the idea of how to capture the tidal wave power. Okay, any questions? I see some. Okay, not questions. Okay, if you have any questions, please raise in the chat room. And then there are pros and cons of these two different solutions. One is, let me repeat, one is this one. You install the generator under the sea. Another is this one. The generator is above the sea, is in the open air, so it's dry and easier for us to maintain. So this is the compressions, the pros and cons. For the air chamber, it's easy to maintenance, but the efficiency is lower. Okay, why? Anyone can tell me why? While the under tap water wave turbine have a high efficiency, but it's difficult to maintain because it's submerged under water, and you need to dive to do the maintenance. Okay, let me see. Okay, I'm asking you questions. Anyone can help me to answer these questions. How can we do? Why the efficiency of the air chamber is lower? It's all come from the wave energy. How come the efficiency is lower? Can anyone enter one single keyword? What is the difference between the air chamber and the water wave turbine? Oh yeah, very good, very good. Okay, Devon and Ken. Yeah, because of the density. Yes, this is the key. The pressure from the air is lower than the pressure underwater. Okay, it's also correct because pressure is also proportional to the density. So yeah, very good. So this is what I would like to tell you about the equations. Okay, that maybe I can. Yeah, is it somebody want to say a few words? Maybe I can jump to here. Okay, related to wafer power. Okay, that I'm going to talk about later. Okay, so the kinetic energy, which is the energy flowing through the channel, is given by this equation. Looks familiar, right? And when we talk about the wind energy, we also talk about these equations, almost identical, except that the energy, the energy is proportional to the flow, okay, the mass flow through this turbine, and also the density, because the higher the density of water compared with air, then the mass will be higher. So in terms of kinetic energy, this M will be larger, right? That's why there's pros and cons. And you can't say which one is better. In terms of efficiency, underwater tap is better, but in terms of easy maintenance, air chamber is better. Okay. Now and then this video, I'm not going to show it now because I suppose you should have watched it, right? Am I right? Anyone have not watched the video before this tutorial? The purpose of the tutorial is that to tell you the key points, while the video lecture have already introduced the details, so you can pay and then you can play slow motions or stop sentence by sentence to listen to my tutorial and lecture clearly. Okay, so I'm not going to repeat this. The purpose of this video is to show you that there are many different designs for how to harvest or to capture the energies in the sea. Okay, some using the flow like this, some using a turbine, okay, and some using a mechanical lever system, and so on. Okay, and the key message is that the innovations is unlimited. You can innovate different types of engineering designs and to fit the applications depending on, let's say, the level of the water wave and also how deep is the seabed. Okay, if there's sometimes it's too deep, then you can't really build this water wave or the tidal wave power plant on the seabed. You need to throw it on the sea surface. Okay, so the design will be a little bit different. Okay, then let's go to the mathematics. Now in this context, you need to calculate the power generated from a dam. Sometimes we call the hydropower from a dam, and also the power generated through running water on the river. Okay, the equations is a little bit different. You need to understand that the power from a dam is because of the potential energy built up by the height. Okay, when you have the water height of h, then the potential energy is density multiplied by gravity multiplied by the height, okay, or the energy is given by mgh, right? Mgh is the energy, total energy of m is the mass of water, okay, g is gravity, and height is the depth of the water dam. And the potential energy per unit volume, if you divide mass by volume, which is the density, okay, so you can have these equations. So the power, which is the energy per second, so you divided the flow by q. Q is the volume of water, so you divided the volume per second. If you have divided on the right hand side by the second, then the right hand side also divide by second. So energy divided by second by the time means the power. So the power of the hydropower of a dam is given by the efficiency multiplied by the density multiplied by the gravity, height, and then the flow rate. So in other words, the faster the flow rate, you have more power, right? And this is linear. So Q is to the power 1. And then G is the gravity, is 9.8 meter per second square. And this 9.8. Sometimes we treat it as 10, but for more accurate calculations, it's 9.8. So this is a factor of almost 10 contribute to the potential energy. Okay, so if in the questions it's given like this, you have 1 cubic meter per second, and then the density of water is 1,000 kilogram per meter cube, and then the flow rate is 10 meter per second square. So this is the gravity, and then the flow rate is 1 meter cube per second. Then you can calculate the total power is 10 kilowatt, okay, assuming 100% of efficiency. Okay, depending on the efficiency, then you can calculate the power. So this is the energies for a water dam, which is contributed by the potential energy. Okay, remember potential energy. Then how about in the river? In the river, when the water in the upstream and downstream are more or less the same, the water level, just like for example in the Twin River, or in a larger river like Changjiang River, Wanghe, this type of large river, the river surface is more or less horizontal, okay, at a certain region. Okay, of course, if you argue with me that from the original upstream, from the origin, where is the locations of the Changjiang? Okay, maybe in Chongqing. Okay, am I right? And then all the way from Chongqing to Wuhan, and then to Shanghai or Hangzhou, Shanghai. Okay, something like that. Yes, the gradient is going downwards, but at a certain region you can treat it as a horizontal, and that's why some ships or ferry can pass through the river. And then the difference between the height, okay, h is very small. So the most of the energies is in the kinetic energy, because the water is flowing quite fast. So the kinetic energy is given by these equations, half mv squared. Okay. So m is equals to the flow rate multiplied by the density. So, and flow rate is also just like what we have discussed last time in the wind energy equations. The flow rate is equals to the velocity multiplied by the cross-section area, right? The amount of water flow for certain distance. Okay, this distance in 1 second is v. Okay, so the flow rate will be given by these equations, and therefore the overall, okay, like this. This is a good diagram. In 1 second, this cylinder of water will move at a distance v. Okay, so for the cross-section area of A, a total volume of V multiplied by A, okay, which is Q, is the volume of water passed through this cylinder. And then if you multiply this VA by the density, which means the total mass. Okay, and then mv squared, and there's a v contributed by the distance traveled by the water. So the relationship between power and the velocity of the water flow is v cube. Okay, remember last time when we talked about the wind energy is also v cube. So the faster the water flow, if we double the water flow, then the power will be multiplied by 8 times because it's cube. Okay, 2 to the power 3 is 8 times. So if you put the number in these equations, when let's say, where is this? Okay, here. So if the flow rate is also 1 meter cube per second, just like last time here, these equations. Here, 1 meter, and then this is the flow rate, and because they don't have this g, the gravity terms, this 10, and then you can see that the power is not that fast, it's not that high. Okay, the power is only about 1/12 of the power of the same volume of flow from the dam. Okay, but if the velocity is double, where it's not 1 meter, it's not 1. Okay, this v is not 1, it's 2. You double the speed, then it will be 8 times already. If you multiply it by 3 times, then 3 cube means 27. Okay, it will be 27 times. Okay, so for the river power is mainly contributed by the kinetic energy and is proportional to the cube of the velocity. Okay. Up to now, any questions? Any questions? Okay. No questions? Okay, and then if no questions, then let me talk about something new that is not we have not touched on in the video. So apart from the energy, no matter kinetic energy or potential energy in the river or in the dam, there's another energy can be stored in water. This is the thermal energy in the because of the temperature differences between the surface and the deep under the sea. Okay, now before we talk about this, let me try to recall the concept of air conditioner. Okay, I suppose you should have learned this before. Yes or no? Tap on the chat room, please. Have you ever learned the concept of an air conditioner? Do you know how it's operates? Okay, come on. Nobody reply. How an air conditioner operates? How come we have some cold air from the air conditioner? Come on. Anyone know that? Or if you don't know, say no, please. From time to time, I want to get some response from you. At least I know that you are still here. Okay, well, are you here? The last reply was at 7:18. Come on. You don't know? Have you ever learned about how? Okay, I use condensing agents. Okay, yeah, it's using some the concept of PV is equals to nRT. Okay, the pressure multiplied by volume is equals to is proportional to temperature. Okay, put it this way. Okay, thank you, Devin, for replying me. Now the operation of an air con is like this. So there is a condenser. Condenser will compress the air. When you compress the air, temperature will increase. The temperature of the air will increase the temperature, and then of course the pressure will also increase. And then this compressed air will go through a expansion valve. So after the air is being compressed, and then when the pressure is released, it's no longer compressed, then it will expand in volume. And these expansions will absorb energies from the surrounding. Because the equations. PV is proportional to T. Pressure multiplied by volume is proportional to T. Now, when you reduce the pressure in this evaporator, and then the volume of the condensing agents as required by Devon's, those condensing agents will then be expand and then absorb energies from the surroundings. Therefore, this coil will be coolant, and then when you have a fan blow through this cool coil, then cool air will flow into the room, and then you will feel very comfortable. Afterwards, this coolant will be compressed again. Okay, so then the volume will be reduced and the pressure increase, and also the temperature will be high. And then this hot compressed coolant will then be flow through a fan, so that this high temperature compressed gas will be cooling down. Okay, and then so the heat, in other words, will be taken away from the indoor to outdoor. This is basically how aircon operate. Now, likewise, because we can make use of the temperature difference to generate motions. Okay, so you need to know that deep under the sea, okay, is cool, 4 degrees, and then on the sea surface here is hot, 27 degrees. Okay, so if we make use of this hot temperature, pass through a evaporator, and then the cool temperature, the cool water deep under the sea will pass through a condenser. So this cool water will be condensed, will compress in the condenser, and then temperature will rise. Okay, just like here, when some warm, I would say warm coolant pass through this condenser, it's compressed, and then it will become hot. Okay, so and then when in the evaporator, so the temperature, and then the temperature of the evaporator will then be increased from 24 degrees to 27 degrees. Okay, so this is the flow. Okay, or you better, it will be easier for you to understand through this diagram, because the number is clear and also the flow directions. So let's start with the deep water. Number 9, the deep water flow into the system at 9 degrees, at 5 degrees Celsius. So it's heat up, and then it's warmer. The wastewater is 7 degrees. So this energy will be increased. And then, so this is the condenser. And on this side, the surface water at a hotter temperature of 25 degrees will pass through this evaporator. Okay, number 2 is the evaporator. And then the wastewater will be cooler, okay, because this is a evaporator, so that the temperature of this intake water will be reduced. So this is a loop. Okay, this loop will form a current loop, and then number 10 is the circulation pump, and then number 4 is a turbine. So you can make use of this current flow to flow through a turbine and then generate electricity in the generator. Okay, so this is the way how we can make use of thermal energy differences, temperature difference between the surface and the deep sea to generate water current. Okay, there's another way to use an open system. Okay, the system that we just mentioned is a closed system, so this loop is closed. Or you can also make use of an open system where the water will flow from the surface water and then flow out to the surrounding. Okay, so the differences is just is that The major difference is that for the closed system, there's a closed loop. For the open system, that the water is not a closed loop, it's a continuous flow in the open ocean. Okay. So this is another way to capture energies from the sea by making use of the energy and the temperature differences between the upper layer and the lower layer. Okay. Now, a similar idea is to capture the energies under the ground, but this time it's different. Okay. We simply pump water into deep under the ground, and then because the temperature under the ground is hotter than the surface, because of the magma under the deep under the ground, that's why we have some hot spring in Japan, Taiwan, or even in some Quaker Bay area. And so cool water pumped to deep into the ground, and then will be heated up, and then warm or hot water will then be collected. It can be used for small scale for domestic use, or it can also be used for the generations of power. Okay, so this is another. For example, in Greenland, they make use of this underground heat to generate power because it's so hot that the water will be heated into steam, and then you can make use of the steam to turn the steam turbine and then generate electricity. Okay, so this is another way to get some clean energy. Any questions up to this moment? Questions, please? No? If not, then let me continue. Okay, then continue to this another part which is very interesting. Now, so far we learned how to reduce the use of fossil fuel, okay, which will emit carbon dioxide. But what if we can't reduce the use of fossil fuel, or the carbon dioxide is already generated in the factory, okay, or power plants or any chemical factories, that there are carbon dioxide is going to be emitted. Now, in order to avoid further emissions of carbon dioxide to the atmosphere and generate the greenhouse gases, then why not we capture this before we release the exhaust gas? Okay, so therefore, this carbon capture is another area that many scientists and engineers are working on. So the idea is to capture it first, or dig a hole in the deep in the ground, and then put carbon dioxide either in a tank or liquefy it, so that you can pump the carbon dioxide into the ground level and store it in the geographical structures of the earth. But this is of course not 100% guaranteed, because there may be some holes in the geographic structures. Okay, so you put the carbon dioxide in those layers, and but it may still escape to the atmosphere. But in the long run, it's good. Okay, there are some way that you can store carbon dioxide or carbon in, let's say, carbon hydrate. For example, calcium carbohydrate, the limestone, which is relatively stable. And unless there's acid rain on the limestone, otherwise it will keep in a state of solid form. Okay, but if limestone reacts with acid, then it becomes carbon dioxide and release back to the air. Right? So there's still some problem. But anyway, this is a way how we can reduce the carbon emissions once it is generated. Okay, so the strategy is first try to avoid the generations of carbon dioxide. But if it is generated, then try to capture it before it is released back to the atmosphere. Okay, so there are 3 ways to do this carbon capture. In general, we can make use of a chemical called amine. Amine, okay, this is a solvent that can dissolve carbon dioxide. So once carbon dioxide dissolved in this amine, in this solvent, so this carbon dioxide is generated from the power plants here. So it will then be reacted with the solvent. So it's absorbed. And if one way is to store this solvent in a sealed tank, and then take a hole and put this sealed tank in the ground. But this is not effective because you cannot reuse the solvent. So another better way is to retreat the carbon dioxide from the solvent and then reuse the solvent. Just like this diagram. I jump to this diagram. When carbon dioxide, which is in the blue circle, mixed with amine solutions, this compound will pass through to another chamber, and where this compound will be heated up, and carbon dioxide will then be collected, and you can then collect it, compress it, liquefy it, and then store under the sea. And on the other hand, the amine will then be recollected and reused to combine with other carbon molecule. Okay, carbon dioxide. Okay, and but still, we do have problem on how to store carbon dioxide. Either in a, as I said, you can compress it and then store it in a sealed tank, but this is also very costly. You cannot do it in mass scale. And but what if you store it in the deep ocean? Okay, now in theory, yes, you can also do that, but then you will acidify the water in the oceans. Okay, if water in the ocean is acidic, then it will also damage to the sea life and also the coral. Okay, anyway, in short, there's no best solution yet. We rely on you how to think of the best solutions to store the carbon. Okay, so this is the way how we capture carbon from the emissions. And how about in the process, when we want to capture the carbon, there are three methods. One is called post-combustion, another is called pre-combustion, and another is called Oxy-fuel combustion. Post-combustion means the carbon dioxide is emitted already. Okay, it's already generated in the power plant. In order to avoid the damage to the environment, we capture it by, this is the fuel mixed with air, you burn, and then you have this carbon dioxide. And so you capture it before the gas is emitted to the atmosphere. Okay, so that you can make use of this idea. Use the amine to do the absorptions. And then another is the pre-combustion. Now, pre-combustion is a little bit different. That is, before the fuel is burned, we try to take away the carbon first. Okay, by doing so, you can, this is the fuel. Okay, on the left-hand side, this is the fuel. So by injecting plenty of oxygen and mixed with the fuel, so we burned. And then in this case, the carbon dioxide, which is the green line, can be captured, because when hydrocarbon is burned with plenty of oxygens, then you can remove the hydrogen and remove the carbon and then turn it into carbon dioxide and store it. And at the same time, the hydrocarbon, the carbon content will be collected through the carbon dioxide. How about the hydro content, the hydrogen, so that you can collect the hydrogen gas. And remember, hydrogen gas is one of the very beautiful gas, as a kind of fuel. One of the reasons is it's light, it's simple, and more importantly is that when you burn hydrogen, it will become water vapor. And water vapor is considered as a green gas. It's not polluting because it does not contribute to the greenhouse effect. Okay. Another one is called Oxy-fuel. That is to burn the fuel with plenty of oxygen. So this is a way that we can collect carbon dioxide and then try to reduce the emissions to the atmosphere. And the advantages is that there's zero emission cycle, as energy stored is sort of fractions removed from the fuel gas stream. And but the problem is that the water will have to treat and dispose properly before the emissions leakage. Okay, because this, apart from carbon dioxide, some water vapor will also be emitted, and then you need to do some treatment. Okay, so these are the three typical way that we can capture and store the carbon. Okay, any questions up to this moment? No? Now, and then in the logs, I have two more slides, but this is out of the syllabus. This is related to the centralized district cooling system that in the Tidal development area. Okay, this is another solutions that can help to reduce the consumptions of electricity for each of the air conditioning system. Now imagine in this area there are many buildings. Talk about 50 building blocks, and each building blocks have more than 20 story. There's 20 floors, and then in each floor there may be up to say 5 to 10 or 20 units. So you can multiply the number. You can see there's like over 1,000 units of aircon, and then if each aircon consumes certain amount of energy and the efficiency is low, then the total energy consumption will be very high. So the idea is to make use of a centralized district cooling system to cool the system, okay, with the seawater, and then cool it, and then the cool water will pass to each building, just like the water pipe, the water source, but this time it's the cool water source to help you to do the cooling. Okay, so this is the idea of centralized cooling system. But anyway, this part will not be examined. Because we don't have the chance to visit this EMSD and the Kinetic cooling system on the site. Okay, in the past, we did organize this visit, but I'm afraid that in this year we cannot do that because of the we need to stay at home. Okay. Any questions up to this moment? Any questions? And let me see the chat box. No? And I noticed that many of you have already submitted the assignment. Any questions related to assignment? Okay. Now, come on, are you still here? Okay, we have 29 students here. Okay. As I said, I prepared something quite interesting to surprise you. And also I want, as a summary, it's a summary of what we have learned. Let me, hang on. Let me give me some time to load this. Okay. Okay, now gases in the air from the group. Okay. Okay, good. I'm glad that some students are still here. So I'm going to show you a summary, a video that summarizes what we have learned in the last few months. Okay, ranging from the renewable energies, nuclear power, and different types of message that I'm going to show to you in this video. Okay, so enjoy. Let's recall the course in climate change. It's not as difficult as what you think. Greenhouse gases in the air warm the group and make us scared. Carbon dioxide make temperature rise. The effect of greenhouse gas is even higher. The season winter will say goodbye. More typhoon and sea level rise. The La Nina effect could cool down the weather. El Nino effect could make the earth warmer. Natural cycle is interrupted by human factor. Let's take actions to make our earth better. Factory farming cut down the logs, cause soil erosions and water loss. So we need another energy source. Renewable energies helps a lot. Nuclear power is clean and cheap, but radiation leakage is the risk. Uranium speech is nuclear fission, while hydrogen bomb is nuclear fusion. Pressurized water reactor is safer. So what to do? Design is better. Moderations change the rate of splitting. Temperature is regulated by cooling. Nuclear safety is top of all. Concrete structures protect the core. Sun energy carries by photons, heat the PV cells and move the atoms. Solar power is also renewable, but it is not reliable. Cloudy day lower light intensity, hot temperature drops the efficiency. Series connects PV cell, a single problem will make it fails. The voltage can rise and save the cost, because smaller currents can drop the loss. Wind energy is also popular. Its operations is simpler than solar. When air flow past the blade, the pressure difference makes it rotate. Power is proportional to area and density multiplied by the cube of velocity. The electric car is quiet and clean. No roadside emission, so it is green. The normal charging time may be long. Fast charging stations demand is strong. Vehicle to grid could be a solution, but charge and discharge may speed up pollution. When the battery life is end, casual disposal must be banned. A new technology could solve a problem, but it may cause another new problem. Smart grid enable energy renewable is turned intermittency supply into stable. Consumer could turn into a supplier, sell energy back to the generator. Smart grid network needs smart meters. Measure the power flow and optimize better. Don't forget smart meter security, or else you may lose your privacy. Our city is reached by air pollution. It's not only caused by car emissions. Under sunlight is a photochemical reaction. PM2.5 is formed and trapped by thermal immersion. While people are getting more wealthy, our environment becomes less healthy. Rubbish are thrown everywhere. Landfill can be found anywhere. Bacterial aerobic respirations cause carbon emissions, but methane is produced from anaerobic respiration. Utilize methane from landfill could generate power better than burning coal, as there's no dust powder. Reducing emission is not sufficient. Carbon capture and storage has to be efficient. The coronavirus knocked us at home. Don't worry, you are not alone. Learn climate change together with your mobile phone. Turn our city to an emission-free zone. Okay, hello. So please turn on your video, okay?
有個漩渦喺度轉。
Hello，邊度講嘢啊？
轉就唔會黐底啦。
哦，
睇下先。
Okay，好啊，Hello，邊個有咩説 ？Hi，
因為我好難咧預算到大家嗰個。
OK，我係知。屋
企即係有啲人咧，佢哋就唔同聽；有啲人咧，可能佢哋咧係開電腦；有啲人咧，可能咧就電腦部。咁其實咧，所以每一個人聽出嚟嘅音量咧，可能都會有所分別。
Oh, I see. Oh, okay. Oh, because of the YouTube is still paying. Oh, how long? Yeah. Where are you? Okay, hello. Okay, wow, thank you. I received a lot of reply. Okay, this is old school, right? Too old school, nice productions. Thank you. Okay, thank you. I thank you for your comment. I hope you enjoy it. Because to be frank, up to now we have already go through many different topics, and then I always talk to my computer. Nobody responds to me except I can read from time to time. Read some text in the chat room, but it's still not good enough. So I want you to remember this course and also remember what you have learned. And hopefully this short video, this RAP, RAP means revisions for you to prepare for the assessment preparations. Okay, revision for assessment preparations can help you to remember what you have learned. And if you like this video, okay, you're welcome to share this video with your friends. Okay, let me share with you the link. Do you know the link? Yeah, I have not told you the link yet. Oh, where is it? Okay. Oh, I didn't send you the link. Hang on. Yeah, how can I do that? Okay, share. Okay. Yeah, our AP is revision for assessment. Okay. So if you like it, okay, you can play it again, and in the next week we will go through some past paper. So please prepare for examination. Now, okay, you can of course watch this interesting grab video to help you to do the revisions, but more importantly is to do the past paper. And next time I will go through some past paper and help you to prepare for the examinations. If you like my video, share with your friends. Okay, hopefully I can be a YouTuber in the future. Okay, so see you next week. Okay, turn on your camera and give me some feedback. 講幾句話俾我一聲回應吧。Okay, yeah. Hello, Elvin. Okay, you're the best. You always respond me. 好，希望大家中意啊。Brandon. Okay, good. Okay. Okay. This is a penguin. Okay, I'll see you 啦，好嘛？好啦，好嘅。Okay, bye bye.
Bye.
Bye bye. Okay.